Okay, next up we have this geometry problem that reads the diagram shows a regular octagon ABCDEFGH and a regular pentagon ABIJK. So the problem here is to get the size of angle X, which is located right here. Okay, so I drew my own version of this just to make my workings clear. So as you see here, it's kind of warped, so don't trust the ratios of the things, but it's a very generic one. So we're gonna look at, first of all, the internal angle of the pentagon. So how do I know the internal angle of the pentagon? A very easy, convenient way that I do it is figuring out how many triangles can the pentagon fit or the polygon fit. So for example, what do I mean by that? I'm gonna quickly draw some lines to see how many triangles can it fit. So apparently there's 3 triangles in a pentagon. So what do I mean by that? So each triangle is going to be 180 degrees internally, right? So I instantly know that the pentagon is going to have internal angle of what? 180 times 3. That is going to be how much? 540, right? Okay, so I'm gonna divide that by how many? There's 5 points, so I'm gonna divide it by 5. And that's going to give me 108 degrees. So I know right off the bat that one angle inside is gonna be 108. And now I'm going to calculate one inside angle of the octagon. So how do I do that? I do the same thing. So I go to the octagon and I draw how many triangles can it fit. Apparently 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So I'm going to multiply what? 180 times 6, which is going to be how much? 1080, and I'm going to divide it by the how many points it has, which is going to be 135 degrees. So I know that the inside angle of the octagon is going to be 135 degrees. And now I know that this little angle right here is going to be how much? I'm going to subtract 135 minus 108, which is going to be 27 degrees. Right? So I know one angle from the triangle IBC, of which I need to get my angle X from. So I'm going to quickly draw this triangle right here, triangle IBC, just to get it clear. Right? Okay, so now I know this is 27 degrees, and now I need to get the angle X, correct? But one thing that you need to notice about the sides of the pentagon and the octagon is that this side, and this side are all the same length. How do I know that? So as you notice, the regular octagon and the pentagon, it shares one side, right? Therefore, since octagon has this side, 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 every side has the same length, same as the pentagon, which has this side, this side, this side, this side, and this side, which is the same length. So we go back to the diagram we drew. So this length is going to be the same as this, which is going to be the same as this. So if we look at this triangle IBC, we're going to notice that these two sides are actually the same length, which makes this triangle an isosceles triangle. What is so special about isosceles triangle? It has the same base angles. So this angle also becomes the angle X. And since we know the angle right here, we can get the X angle by adding it up and making it equal to 180 degrees, which is equal to the sum of the internal angles of a triangle. So we're going to get 27 plus 2x equals to 180. Right? So 2x equals to how much? Equals to 153. And then we get the x angle, which is 76.5 degrees. So the answer to this problem was 76.5 degrees. And how do we know that? We knew that by understanding that the sides of a regular pentagon and an octagon are actually equal, and so we had to find out that the triangle was an isosceles triangle with the base angles the same.